I'm going to explain the tidal force because the tidal force is a key force to understand many processes in astronomy. Tidal force. We start with the motion of the point mass. The point mass. There is no size. Point mass doesn't have any size. So in this case, no tidal force. We start with a really simple case. Okay, so we consider the two objects making a circular motion. Central object has a mass of the capital M, rotating around the point mass with a mass of the lower case of the M. And then in this case, two forces acting on the point mass. One force is gravity. The other force is a centrifugal force. These two forces balance at the same magnitude but opposite directions. Then particle can move on the same distance from the other object. Distance between the two objects is remains a constant value of the r. Then equation of motion. Or we could say the force balance equations can be expressed. Centrifugal force is equal to the gravity. Then in this case, centrifugal force can be expressed. Rotation speed of the object is v, then centrifugal force is expressed m times b square over r. And gravity, this is centrifugal force. Gravity is expressed g, product of the two masses, over r square. So this is the equations, motions. Then I'd like to find out the angular velocities of this object. Angular velocity. Angular velocity is omega, is expressed v over r. So the angular velocities is a particle is moving the circular motions is r. This is omega. Then particle is moving r omega. This is a v. So omega can be expressed b over r. So this is angular velocities. So from the equation of motion, force balance equations, m b square over r equals g m over r squares. We can cancel out the lower case of the m. And the v equals r omega. You can substitute this one and then r omega squares over gm over r square. So from these equations, omega can be obtained gm over r cube. This is the angular motion of the object of the point mass. Now we'd like to consider the object with a finite size. Finite size rotating around the central object. Now we consider the object is rotating. Then if the object is moving to the new position of this one, actually the angles, this angle of the theta is always constant, even if you consider the most inner part or the outer part. So this means omega is always constant. Then we'd like to start considering the equation of motion. Go back to the equation of motion. m v square over r over g m capital M over r square. Then m is cancelled. If you consider the unit mass of the object, this is centrifugal force. Force is expressed v square over r, or r omega squared. This is centrifugal force. And the gravitational force is expressed g capital M over r square. This is gravitational force. We'd like to consider these two forces. Now we consider circular motion with a finite size of the object. Central object is placed at the centers and the finite size of the object. And the size of this object is expressed delta r. And circular orbit has a radius of the r. Then we'd like to consider the centrifugal force acting on this object. Omega is a constant. So this is centrifugal force is dependent of the distance from the object, central object. The inner part is actually a smaller, shorter distance from the centers. So centrifugal force is weaker because this is r minus delta r omega squared. Omega is constant. And in the outer edge, distance becomes longer. So r plus delta r omega squared. So this is larger centrifugal force in the outer edge, and in the inner edge, smaller centrifugal force is acting. Then we'd like to consider the gravitational force. So this is r is g and m is constant. Only the r is dependent on the distance from the central object. The inner part, inner edge, has a shorter distance. So gravitational force becomes stronger. Gm over r minus delta r squared. And the outer edge, this becomes smaller gravitational force is acting on the outer edge. Gm over r plus delta r squared. Okay, so this is the equations. Then we have a different magnitude of the force is acting on the inner edge and the outer edge. Maybe I should write that one more times. Outer edge, stronger centrifugal force, and the weaker centrifugal force. And outer edge, weak gravitational force, and the stronger gravitational force is acting. Then you could consider sum of the two forces. So in this case, sum of the two forces becomes this one. This is centrifugal minus gravity. And also the inner edge. Gravity is stronger. So gravity minus centrifugal. So there is not zero force. These are non-zero force is acting on this object. We call this is tidal force. So tidal force is equal to the actually difference of centrifugal force and gravitational force. We'd like to find the expression of the tidal force at r plus delta r. Then centrifugal force is expressed r plus delta r omega square. And gravity is expressed g m over r plus delta r squares. So this equation is expressed r squares over gm times 1 plus delta r over r to the minus square. Okay, this is negative sign. So be careful about this is negative sign. This is positive sign. Okay, so you can it becomes this one. So in the case of the epsilon plus 1 plus epsilon to the n, you can easily expand using the binomial functions n epsilon plus n plus minus 1 over 2 epsilon squares plus blah blah blah. Or you can easily imagine that this is a product 1 plus epsilon, 1 plus epsilon, 1 plus epsilon, blah blah blah, 1 plus epsilon to the n. So n times product. Then if you take only the 1, 1, 1, you can find the first terms. And if you take only the epsilon from the one of the parentheses, you can find the epsilon. Then there is n choices. Then in the case of the epsilon is much smaller than ones, we can approximate. It becomes 1 plus n epsilon. So we use this formula to approximate this equation. This becomes gm over r squares 1 minus 2 delta r over r. This is correspond to the n. And this is correspond to the epsilon. If you remember the omega. Omega is a square root gm over r cube. So this means this is equal to the r omega square plus 1 minus 2 delta r over r. So this is going to this equation becomes r omega. So using this. Okay, then it becomes r omega squares minus 2 delta r omega square. This is gravity. Then we'd like to find out tidal force. In the centrifugal force. Force minus gravity. Centrifugal force is this one. R plus delta r omega squares minus this is gravity r omega squares minus 2 delta r omega square. Then r omega square is gonna be cancelled out, so the answer becomes 3 delta r omega squares. This is the magnitude of the tidal force. This is the end of this practice.